Okay, so we're asked for a couple of things for this problem here. First, it says on graph paper, copy the vectors shown to the right. I'm not doing that because I'm just copy paste. Draw and label each of the following vectors. Leave room to separate each answer from the others. So, okay, P is a vector equivalent to vector V. So equivalent meaning it's going to have the same direction and magnitude. And so in this case here, what I see for vector V here is that it's going over 1, 2, 3, 4, 5, 6, 7, 8 to the right and down 1, 2, 3, and 4. So I'm going to redraw another vector somewhere else, and that's equivalent, meaning same direction, same magnitude. So 8 to the right, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4 down, still pointing in that same, let's see if I can actually get this to look like a straight line. I can't. Trust me, this is straight. Just pretend. That's my straight line. It's getting worse. Oh no. Okay. One last try. That's as straight as it's getting, people. Second part here is adding vector u and z. So to do that, I'm going to draw u first. So again, u is 1, 2, 3 to the left and 1, 2, 3, 4, 5 up. So starting here, 1, 2, 3, 4, 5. 1, 2, 3. So that's vector u. And then to add, I'm going to tack on this other vector z here, which is 1, 2, 3 to the left and 1, 2, 3, 4, 5 down. So 1, 2, 3, 1, 2, 3, 4, 5. Tack that on to where we ended here. That's vector z. And so when I add them together, I'm looking for the resultant vector, which in this case starts at where we started from, ends at where we ended at. And when I count this, I see 1, 2, 3, 4, 5, 6 to the left and 0 up or down. So the way I would write this is -6, 0. That's my resultant vector. Okay, for C here, we're asking for 1/2 of V, right? So if before for P we did 8 to the right and 4 down, now for half of V, I'm just going to do half of each of those terms, right? So originally we had V, which was 8 to the right and 4 down. I'm just going to multiply each of those terms by 1/2, and I get a vector that's 4, -2. So 1, 2, 3, 4, 1, 2, and then my line here. There's 1/2 of vector v. And last one here is vector u minus vector v. And so when I do that, I'm really just converting it kind of into addition. So I'm going to draw vector u first. And vector u here was 3 to the right and 5 up. So I'm going to give us a little more space. Start down here. 1, 2, 3, 4, 5. 1, 2, 3. So there's vector u. And then subtracting vector v, again, going back to up here, vector v was 8, -4. So when we subtract that, it's just like distributing a negative in there. So it's really going to be going, instead of 8 to the right, 8 to the left. Instead of 4 down, it's going to go 4 up. So when I do this, I go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And there's my vector, which we're going to call negative vector v. And so the resultant vector is just from wherever we started to wherever we ended. In this case here. So my resultant vector of u minus v, or you can consider it u plus -v.